For our math warm-up today, we have 4 division and multiplication problems here using exponents. So I want you to go ahead and number your paper or your dry erase board from 1 to 4. Pause your video and see if you can figure out what our answers will be. All right, let's see how you did. 500 divided by 10 to the second power is 5. 3 1/10 times 10 and to the second power is 310. 15 times 10 to the third power is 15,000. And 37 3/10 divided by 10 to the second power is 0 and 373 thousandths. How'd you do? For our math message today, you're going to go ahead and take out your workbook and open it up to page 201. And at the very top of the page, you will see your math message is question number 1 on that page. So we have a problem here with an in and out box. It says that there are 100 centimeters in a meter. Use this information to write a rule in the function machine. Then complete the what's my rule table at the right. So here's our function machine. We have to figure out what the rule is going to be to go in here. And then you're going to complete this in and out table here to the right. So go ahead and pause your video and see if you can figure that out. Okay, so let's see here. The rule in my book would be times 100. Did you put the same? So let's check it out and see if it works. If I put the number 1 in the top of this machine and then multiply that 1 times 100, what do I get out? 100. So it does work with that first one. So then we would go ahead and complete the rest of the table, with 2 being placed in times 100 would be 200. 3 being placed in times 100 would be 300. 4 in the machine times 100 is 400. And 5 placed in the machine times 100 is 500. How'd you do? So the title of our lesson today is Application Converting Measurements in the Metric System. The reason we are doing this lesson today is first, we need to be able to gain an understanding about the metric system and how it relates to powers of 10. And second, we want to be able to work with volume and mass or weight. And how are we going to do about that or go about that? We are going to practice converting units using real-world problems. So part of your work today is going to involve in and out tables or in and out boxes or rule tables, however you want to look at it. So I've got an example here we're going to take a look at. So if we look at part A, it says convert between grams and kilograms. So those both are in the metric system. We have an in and out box over here, and then we have a rule machine here. So it tells us that we need to write a rule that we could use to convert from kilograms to grams. And they're giving us a hint. How can you find the in number if you know the out number? So we're going to think about some of those things as we go about this today. So first of all, when I think about grams and kilograms, in order for me to do any kind of conversion, I need to know what the 1 is. And they just so happened to give that to us in this table. We know that 1 kilogram is equal to 1,000 grams. So 1 kilogram is equal to 1,000 grams. So that's going to help us when we look at our table and try to figure out a rule that we need to write in the box. So if I put 1,000 in and I only got 1 out, what would be my rule for that? If I put 1,000 in and I only got 1 out, what am I doing to that number? So let's take a look here. If I made the rule divide by 1,000, let's see if it works. So we're putting the number 1,000 into this machine, and we're going to divide by 1,000. So 1,000 divided by 1,000, does that equal 1? Why, yes, it does. Okay, so if we put 2,500 in and divided by 1,000, what would we get? We would get 2 5/10. So now if we put 250 in the machine and divide by 1,000, what would we get? 0 and 25 hundredths, because remember, our number is going to get smaller. Now it looks like we're going the opposite direction. So now we have 8 in the out spot. So if we divided when our number was over here, what are we going to do if we're starting over on this side? We're going to do the opposite of division, which is multiplication. So we would do 8 times 1,000, which would give us 8,000. And for the one underneath that, we have 8/10. So we would multiply that times 1,000. And think about how many zeros you have in the number 1,000, right? Think about your exponents, how that might fit in. So our answer there would be 800. And then our last one, we have 0 and 8 hundredths. We multiply that times 1,000, and that is going to give us 80. Now, thinking about your exponents and how you could write a rule down here. Write a rule you could use to convert from kilograms to grams. Hint, how can you find the end number if you know the out number? We're going to use an exponent. So in that spot, I'm going to write times 10 to the third power. Because remember, we're using the number 1,000, and 1,000 has 3 zeros. So that should give you a clue there as far as what your exponent would be. Now, this is just a sample of one of the pages that you'll be working on in class. We're going to take a look at some real world problems next. Okay, so we have a pretty lengthy real world problem today. And I'm going to have you pause your video and go ahead and read that to yourself to kind of digest it a little bit. And once you finish reading, go ahead and come on back. So there was a lot of information in that problem, and as you may have noticed, I have highlighted some very important things to pay close attention to. So first of all, we have kilograms here. This is grams, this is grams, this is grams, this is grams, but yet our question says how much do Quentin's items weigh in kilograms. So the first thing that we might want to do is go ahead and take all of those units of measure that are in grams and add them together. So let's make a list here. we have 907, 150, 725, and 4,500. And remember, these are all listed in grams at the moment. And what we're going to do is add them together and then convert them to kilograms. Okay, so I've added those together, and now if we take a look, all of those items equal 6,282 grams. But again, the question is asking, how much do Quentin's items weigh in kilograms? So we need to go back to, what is the one? 1 kilogram is equal to 1,000 grams. So if we have 6,282 grams, are we going to divide or multiply times 1,000? Hopefully you answered divide. So we would need to do 6,282 divided by 1,000. And what we could do is remember that your decimal point currently is right here. The fact that we have 1, 2, 3 zeros and we're dividing, we're going to move that decimal point to the left 3 places. So here's 1, 2, and 3. So our answer would be 6 and 282 thousandths kilograms. So the answer to the first question, how much do Quentin's items weigh in kilograms, would be the 6 and 282 thousandths kilograms. The second question is asking, will his luggage go over the weight limit? Well, the beginning of this told me that his luggage can weigh up to 23 kilograms. He's not even close to 23 kilograms, is he? So the answer to that question would be no. It does not go over. So again, lots of information there. We've got to pay close attention. Make sure that you read carefully. Make sure that you look at those units and determine what needs to be converted and how you're going to go about doing it. So let's summarize what we've talked about. We have learned that the metric system works well with powers of 10 because we could see that we could use exponents in some of those problems. We also discovered that solving real-world problems requires reasoning through multiple steps, as we saw just a few minutes ago. And it helps to have some guiding questions to get through the process. For example, what units need to be converted? So again, making sure that we're paying attention to those units. How are they related? And what rule can I use to convert them? So it might be the rule of dividing by 1,000, or it might be multiplying by 1,000. It might be multiplying by 100. It just depends on the relationship for the units that you are converting. So metric system works well with base 10 and powers of 10. So just remember that and think about which way those decimal points are going to move. Until next time.